Hello and welcome to another video. In this one, we're going to talk about wheels and what they mean for Python. And let's jump into it. Okay, so the name wheel seems a little bit weird, and admittedly, it's kind of a long-running joke that even I don't really understand. The nature of this joke comes from calling PyPI, which is the Python package index. It has the nickname the cheese shop, and uh, a wheel is like a wheel of cheese from the cheese shop. I don't know. I'm not gonna even try to understand what it means there. But I'm gonna talk to you about what wheels are, and what the file name is special about, what they're structured inside, how you can go about installing them, and yeah, I think we'll cover that. Now, before wheels, there were two ways to install packages. There was from a source distribution, which is either a zip file or a tar.gz or any other compressed archive. And you would install from source, meaning anything you had to build, you would have to build it yourself when installing. There was a pre-built package that was called an egg. Eggs are actually very similar to wheels in a bunch of ways, but eggs fell out of fashion because they involved weird Python path hackery and didn't really set up stuff in a super well-defined way on disk, and wheels provided a much more stable and reasonable way to do that. The current modern approach to packaging, you typically can install pretty much everything from a wheel, and rarely need to use a source distribution. I say rarely. There are actually quite a few examples where you would use a source distribution. We're not going to go over that today. But what a wheel represents is it's a pre-built package that's installable just by unzipping the archive and not running any code, which can be really important for both performance, because running code on installation, building stuff from source takes a long time. That can slow your stuff down, but it's also useful for security. So if you're installing packages from wheels, you tend to not be running arbitrary code from the internet. You're really just unzipping files into the destination state. Now, I've downloaded a bunch of wheels ahead of time to kind of show you how they're named. I happened to pick a bunch of different ones to hopefully highlight some various things about them. And we'll also go over the structure of what's inside of these wheels. I mentioned earlier that source distributions can be zips or tarballs or any sort of compression state. Wheels are always have the file extension WHL, and they are always zips. So these are just fancy zip files that have a different extension and a very particular naming convention. Now, the naming convention is split up into components. Each component is separated by a dash, and the first component is the name. So you can see this first wheel is the AST pretty wheel. Note that if there are dashes in the name, they get normalized to underscores. So you can see here Babby grammars is actually Babby dash grammars according to pip, but you're always going to see an underscore in place of those dashes there. The second component is the version number. So this is the version number of whatever library. So in this case, I have AST pretty equals 1.7.0. You can see the version numbers for some of these other ones. And then the last part of the wheel, or the last three components, and these are usually kept together and referred to as a platform triplet. Other people call them other things. That's what I've heard them referred to as. The first component of this is the Python versions it targets, and there's a couple of different things you'll see here. In this case, this is py2.py3, and note that a dot in any of these three platform triplet components means kind of an OR relationship. So this supports both py2 none any and py3 none any, and this dot is kind of like a curly expansion in Bash, where it can be any number of those things. And sometimes these dots get a little bit ridiculous. Like you can see here, this one is ManyLinux 2.5 x86-64, or ManyLinux 1 x86-64, or ManyLinux 2.17 x86-64, or ManyLinux 2014 x86-64. And so this third component can be any of those things. Now, I talked about the first component. The first component is the Python version that it targets. You'll see py for pure Python things. This means it doesn't have any binary artifacts, doesn't have any C extensions, that sort of thing. So you'll see py for that. And typically you'll see either py2, you'll see py3, and very rarely, occasionally, you will see something like this, where it has a specific minimum version number. And note that this platform tag, or this I guess language version tag, implies any version after that. So Pi 3.6 is going to represent, is going to be installable on 3.7, 3.8, 3.9, 3.10, etc. on into the future. In the same way that Pi 3 is installable on any Python 3 version. Now there is a bit of a asterisk there. Pip does adhere to major versions here, so if you saw just Pi 2 here, that wheel would not be compatible with Python 3. And in the same way, by seeing Pi 3 here, it would not be, well, we don't actually know because Python 4 doesn't exist, but presumably if it followed the same pattern that Python 2 and Python 3 did, the Pi 3 wheel would not be installable in Python 4. You will also occasionally see, well, pretty frequently see a implementation type here. So this was pure Python with just py. CP here means that it's a CPython specific wheel. This usually means that it contains some sort of binary artifact, a .so file, a DLL file on Windows, a PyD file on macOS. Oh wait, is that right? I don't know. Either way, a binary extension. And so you'll see this as the language version here. So this is saying at least CPython 3.8. Now note I say at least here, and we'll actually get to some fiddly edge cases in a bit. Actually, we can just get to them right now. But when we'll talk about ABI, there are actually ways that this does not mean the exact version, but only the minimum version. The ABI is actually what determines with this what the minimum version is. So in this case, like, the ABI is exactly the same as the language version, and so this is only installable on CPython 3.8. You'll also see PP. PP is for PyPy, and I think only CPython and PyPy currently have language version or language tags. I don't think any of the other implementations are allowed to upload wheels at the moment, but presumably you could imagine one for like Jython or whatever other platform you're targeting. But generally, when you're looking at things, you can assume that Pi 2, Pi 3, that means it's pure Python. If you see CP or PP, that means it has non-pure components, a compiled component inside of it. Okay, so that's the first component. The second component is the ABI, the application binary interface. And for wheels where it doesn't matter, so they don't have any binary components, so you don't have a binary interface, you'll see none as this second tag here. And this is very common if you have like Pi 2, Pi 3 none, or Pi 3 none. This is pretty much what you're always going to see for a pure Python component as the second chunk of this triplet. Now, for non-pure things with compiled extensions, such as this one that has CP36 as the Python, you will see the ABI usually matching that or having some flags after this. In this case, this is the CP36M, M being PyMalloc, which was made irrelevant in Python 3.8 because it doesn't actually participate in the application binary interface. Did I do a video on this? I think I might have. Maybe not. But yeah, this will say that this has to be installed on something which supports the CPython 3.6 M being PyMalloc binary interface. You may also see D if I don't think I've ever seen someone distribute a debug wheel, but you might see D in that case, or you might see something like ABI 3. And I did another video on ABI 3, so I will link that in the description. But what ABI 3 means is that this wheel supports the Python minimal ABI at least this version. So this is saying at least Python 3.6, but targeting the minimal ABI. And this basically allows you to install this wheel on any particular CPython 3.6, 3.6 or above, assuming that they don't break the ABI, the ABI, which may happen at some point. We may see an ABI 4, and then you'd have to have another iteration of this. For PyPy, they have a bit of a special ABI platform tag. So PyPy currently doesn't support ABI 3, so there isn't really. Actually, that might have changed by now. I haven't researched that topic in a while, so it may already be solved. But PyPy has both a language version that it targets, so in this case it's 3.7, Python 3.7, but they have their own internal version number as well. And so this 73 here is actually PyPy 7.3, which is a particular release of a 3.7 language, because PyPy has kind of two separate version numbers. And so their ABI tag is a little bit different. Okay, so that's the language version tag as well as the ABI version tag. The last component is the platform tag. And again, if you have a pure Python without any binary components, you'll typically see any as the tag here. And this is saying, we don't have any non-pure components. You can install this on any platform, Windows, Linux, Mac OS, any. But if you see a particular platform, so for instance, we have the Many Linux 1 x86-64 platform here. This I did a video on Many Linux, so I'll link that in the description, but the TLDR is this is a platform tag which says any particular Linux that has this minimal symbol set can be installed there. We also see a Many Linux 2010 here, which is a slightly newer version of that standard, or the newest version of the standard, which has the glibc version number here. We also had a Mac OS wheel here. There's also platforms for Windows as well. The third component is kind of that platform component. And again, like if you see a dot in these, this supports many different platforms, but the installer can choose which of these to pick. Okay, so that's the file name, and admittedly the file name is probably the most complicated part of this and probably the most part to understand. The rest of it is mostly just the structure of these. So I'm going to take a look with the unzip tool to list the contents of these and kind of go through the various things that you'll see in here. So let's start with ASD-Pretty. This is kind of the simplest case. We do unzip-l this. It's going to show us, green, of course. It's going to show us the contents of this wheel. Now, generally, an ASD-Pretty is pretty simple. It just has a single Python file that it distributes. Generally, the top level of your wheel is what's going to end up inside of site packages when you install this. So when I install ASD-Pretty, I'm going to see ASD-Pretty.py. I'm also going to see this dist-info directory. This dist-info contains kind of installation metadata, things about the version, the README, the license. Entry points is how it decides how to make console scripts, as well as record, which pip actually modifies later to indicate what files are installed or not. So this, I believe, actually also contains hashes for each of these files as well. Actually, let's just unzip that and take a look at it. Unzip ASD-Pretty. Oh, the tab complete does work. Unzip used to not understand that wheels were zips, and so it wouldn't tab complete there. Okay, so this is what we get after unzipping. And this is actually very similar to how pip would install this. So pip is going to treat this as a zip, unzip the contents into site packages, and then move some stuff around, basically. And if we take a look at the dist-info here, we'll just take a look at all these files. The first one we see is console scripts. This is what tells pip to set up a binary called ASD-Pretty, which is the main function. And so when you type ASD-Pretty in the terminal, it'll run that command line tool. Here's the license file. This is the metadata file that I was talking about before. This gets generated from either setup tools metadata or whatever other packaging utility you're using. I guess fields that don't get filled out show up as unknown, which is kind of interesting. You can see down here we have the Python requires. I guess this was an old wheel of ASD-Pretty, which still supported Python 2, as well as you get the long description down here as well, which in my packages is just the README. And you get all the classifiers. And yeah, here's the record file that I was talking about before, which basically lists all the files as well as a checksum. And you can't see it. Hold it down a little bit. But it also contains the size of those as well. So you could, this is kind of a internal checksum of all the files. Record, of course, does not have this because you can't really know what its checksum is going to be before generating it. And so these fields are kind of empty. So it doesn't know the size, it doesn't know the checksum, but you can't really have a self-referential checksum, so that's why it's that way. This is top-level.txt. I think this gets used for uninstalling and reinstalling, but in this case, there's only one top-level module. And wheel contains metadata about what actually generated this. So in this case, I used wheel 0.33.4, and you can see these are the two tags that it generated, and that it's kind of the expansion out from this dot here. So we got two tags there. We'll probably actually be able to see this one have a whole bunch of tags. Actually, do that right now. Yeah, unzip this */wheel to -o. Nope, it's -p. Yeah. So you can see here that those 4 platform tags got expanded out like this. And we actually generated this. We don't need. Cool, so that's the contents of a normal wheel. So you'll typically see something like that. Let's take a look at some wheels that have some more complicated things. So those are only 2 of the 3 components. There is a third component called the data component. And there are 3 types of data. Let's take a look at this. I've specifically picked a few wheels that have those 3 types of data. It actually took me a bit to hunt for this one, which we'll look at in a second. But if we do unzip-l this and pipe that to less, you can see this package actually has a bunch of files, and interestingly, I can't really see it on that screen. Unzip-l Babby grammars. But interestingly, this package actually doesn't provide any Python files. This actually only installs data. So this is that third component that I was talking about, the .data directory, and this is treated specially by the installer. In this case, and it's based on the path segment after the data directory. So .data/data means that these are going to be installed directly into the prefix of your environment. So if we were to do /vf, and we did pip install Babby grammars, you'll see inside of our wheel, we got the shared directory that contains all of these files that are listed here. And that's just directly at the root of this prefix. And it didn't actually install anything into vmlib except for that distinfo directory, kind of the metadata of that package. But that's .data/data. And you can see here, there's a whole bunch of data files. There's also a whole bunch of license files, because this happens to aggregate a bunch of grammars from various different sources, and also contains that wheel metadata that we talked about before. So that's .data/data. Let's take a look at Greenlit next, which contains a little bit different of a setup. Unzip-l this. This has a bunch of stuff that's going to get installed into site packages. So you can see there's a shared object here that provides the compiled C extension, and that shared object, again, is compiled for a particular platform and Python version. There's a bunch of pure Python stuff. We also have the distinfo directory that we talked about before, but we have this data/headers, and this is a little bit different than data/data. This is going to get installed inside of a include directory on Linux. It's going to vary based on the platform, but on Linux, if we do pip install greenlit, you'll see that greenlit.h ends up inside this include site Python 3.8 greenlit.h directory. It's actually kind of weird. I kind of expected it to just end up in the top level, but I guess it doesn't necessarily work the way I expect it. But yeah, that greenlit.h ends up in this special include directory, and again, the installer tool manages this directory specially. But beyond that, all of this ended up in site packages. Lib site packages, and so you can see the greenlit directory as well as the greenlit distinfo. And the last thing is scripts. AWS CLI happens to have one of these. So if we go down, again, these are just going to get installed in site packages. They're just normal files. And we have a lot of stuff here. Shift-G to go to the end. And you'll see we have that distinfo directory we talked about before, but we also have this special scripts directory. And this is going to get put into the bin directory on POSIX Link platforms, and it's going to get put into the scripts directory on Windows platforms. So that's kind of the third special case. So there's basically five ways things get installed. They're at the top level, they end up in site packages. They're in distinfo, that also goes into site packages. And then there's data, which is just from the prefix downwards. Then there's data scripts, which gets put into the bin directory, and it also has some shebang normalization. And then there's data include, or data headers, which goes into the include directory. And so that's basically all there is to the wheel structure. And installing them tends to follow 2 steps, at least with pip. Like, one, unzip the files and put them into the right place. And then the second thing is to take those entry points, which this one does not have entry points, but this one does. p/entry points.text is to take these entry points and write out the little script wrappers into the bin directory, or .exes on Windows. So if we look inside vmv bin, did we not install it? We did not. Pip install astpretty. And if we look in vmv bin astpretty, this was generated from this console scripts here. And you can see that it's kind of a script that just imports the entry point astpretty main, what this is here, and then runs it at the end. And so that's how a wheel gets installed. Yeah, I think the last thing that I want to talk about here is there are some platforms that are going to look a little bit weird. Like before I mentioned that Pi 2, Pi 3 typically means that it's pure Python, but you'll see I actually have an exception here. This wheel is Pi 2, Pi 3 none, which typically to me says, pure Python. It doesn't contain any Python extension components. None means that there's no Python ABI specific components. But then at the end it says many Linux 1, which means that there are binary components in it, but it doesn't matter, like the Python version doesn't matter. And actually what's happening here is kind of clever. This is distributing a different binary, but using the Python packaging system. Another one that does this is pip download dumbinit, which is a Docker init system. And so we see this also has that Pi 2, Pi 3 none, so it doesn't contain any Python components, but it targets these particular Linux-like platforms. And so that's kind of a weird one you'll see. I also picked out this one because it's weird, but we already talked about it earlier, where this was supposed to indicate that it's Python 3.6 and above. But typically Python requires is used instead of that specific tag nowadays. Do I have any other weird ones? No, I think that's mostly it. Cool. Yeah, so that's wheels. I know there's a lot to take in here. But most of the complexity is around just the file name and understanding what each of the components do. And then, they're just zip files. They're not really anything magical beyond that. But hopefully this was interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.